All right, so here we are at the next lesson in geometry. This lesson is called Similarity Word Problems. So it says you can use similar triangles and measurements to find distances that are difficult to measure directly. This is called indirect measurement, okay? Indirect measurement. You're not measuring it directly, you're measuring it indirectly. Indirect measurement. One common problem involving indirect measurement uses the fact that light reflects off a mirror at the same angle in which it hits the mirror. Another common problem uses similar triangles that are formed by certain figures and their shadows. So I have some of each of those examples today, as well as some others. So here's example one. Nina was curious about the height of the Eiffel Tower. So she can't measure that directly because it's too tall. But what she's going to do is she's going to use a 1.2 meter model of the tower, and she measured its shadow at 2 p.m. The length of the shadow was 0.9 meters. Then she measured the Eiffel Tower's shadow, and it was 240 meters. What is the height of the Eiffel Tower? Okay. So again, the reason why you can solve this problem is because you have similar triangles. So I'm not sure if you can see it, but this is a right angle right there. That's a right angle. And this is a right angle right here. And the angles formed by objects in the shadows, these are congruent. So this angle is congruent to this angle. And then you have the right angles. So two triangles are congruent by angle-angle similarity. So I'm going to write a proportion and solve. Make all your numerators come from one triangle, and make all your denominators come from the other triangle. So I will do x over 1.2. Okay, equals. Make sure all your numerators come from one triangle, and all your denominators come from the other triangle. So if I do x over 1.2, I'm going to say that equals 240 over 0.9. Cross multiply and solve for x. 0.9x equals 240 times 1.2. 240 times 1.2 is 288. 288 divided by 0.9 gives you 320. X equals 320. So since it's a word problem, you can put that in a sentence. The Eiffel Tower is 320 meters tall. I don't know if that's accurate. It must be accurate. I don't know. I'll look that up later. Okay. I have 6 examples today. Here's example 2. It talks about problems with the mirror. Okay. Natasha places a mirror on the ground 24 feet from the base of an oak tree. She walks backward until she can see the top of the tree in the mirror, in the middle of the mirror. At that point, Natasha's eyes are 5.5 feet above the ground, and her feet are 4 feet from the image in the mirror. Find the height of the oak tree. So again, the reason why you can solve this problem is because you have similar triangles. This is a right angle right there in that triangle, and that's a right angle in that triangle. And the angle that light reflects off the mirror is congruent. So this angle is congruent to this angle. So two triangles are congruent by angle-angle similarity. So now let's write our proportion and solve. Make sure all your numerators come from one triangle, and make sure all your denominators come from the other triangle. So I will do 4 over 24 equals 5.5 over x. Cross multiply 4 times x equals 24 times 5.5. So that means 4x equals 132. Okay. 132 divided by 4 gives you x equals 33. So put that in a sentence. The oak tree is 33 feet tall. Example 3. I don't know how to pronounce this. To estimate the height of the Jin Mao Tower in Shanghai, a tourist sights the top of the tower in a mirror that is 87.6 meters from the tower. Okay, 87.6 meters from the tower. That's a mirror right there. The mirror is on the ground and faces upward. The tourist is 0.4 meters from the mirror, and the distance from his eyes to the ground is about 1.92 meters. How tall is the tower? Okay, so again, we have similar triangles because this is the right angle right there. I'm not sure if you can see that. That's a right angle. And this is the right angle right here. And this angle is congruent to this angle. So let's set up our proportion and let's solve. Make sure all your numerators come from one triangle and make sure all your denominators come from the other triangle. So I'll do 1.92 over x, I guess, equals 0.4 over 87.6. So remember, there's more than one way to set up your proportions. But now let's cross multiply and solve for x. So 0.4 times x equals 1.92 times 87.6. So 0.4x equals 168.192 divided by 0.4. And you get x equals 420.48. I'm not sure if it tells you where to round. Let's see. It doesn't tell you where to round. You can round however you'd like. I'm just going to leave it like that. So I'll say the Jin Mao Tower, or Mayo. I'm not sure how to say that. I'm sure I've heard of that before, but I don't remember how it's pronounced. Is 420.48 feet tall, meters tall. Okay. We got 3 more. Example 4. Keenan wants to measure the height of the Sears Tower in Chicago. If you know what show this is from, shout out to you. Okay. Keenan wants to measure the height of the Sears Tower in Chicago. He uses a 12-foot light pole and measures its shadow at 1 p.m. The length of the shadow is 2 feet. Then he measured the length of the Sears Tower shadow, and it was 242 feet at the same time. What is the height of the Sears Tower? Now, you might want to draw 2 separate triangles if this is confusing. If they're like overlapping, that's confusing you. This one, I don't think we need to do that though, okay? Drawing not to scale. I'll set up my proportion. I'll do 12 over x. Again, make sure all your numerators come from one triangle and make sure all your denominators come from the other triangle. So I'm doing 12 over x equals 2 over 242. Cross multiply and solve. 2 times x equals 12 times 242. Two times x equals 2,904. Divide that by 2. X equals 1,452. And that is accurate. I do know that off the top of my head. The Sears Tower is 1,452 feet tall. Two more. Two extension ladders are leaning at the same angle against a vertical wall, okay? So again, they're leaning at the same angle, so it means that this angle is congruent to this angle. And both triangles have this right angle, so angle similarity again. Just like the last one was also angle similarity. But, here we go. The 3-meter ladder reaches 2.4 meters up the wall. How much further up the wall does the 8-meter ladder reach? Okay. This one might be a little tricky. And again, you might want to draw two separate triangles for this one. I don't think you have to, but I'm just going to do it just in case you want to. So this is 3 meters. This 2.4 meters. And the bigger triangle. This will be 8 meters. And I'll call this one X. So let's write a proportion. Make sure all your numerators come from one triangle. Make sure all your denominators come from the other triangle. I'll do 2.4 over X equals 3 over 8. So 3 times X equals 8 times 2.4. 3 times X equals 19.2. X equals 6.4. Now that is not your final answer. That 6.4 tells you how far up the wall the ladder reaches. The question is how much further up the wall does the 8-meter ladder reach? So what you have to do is you have to do 6.4 minus the 2.4. And that gives you 4. So in a sentence, the 8-meter ladder reaches 4 meters higher up the wall. Okay? Reaches 4 meters higher up the wall. If I asked you how high up the wall does the 8-meter reach, then you would say the answer is 6.4. But the question said how much higher up the wall does that reach as opposed to this ladder. So 6.4 minus 2.4 gives you 4, and 4 meters is your answer. And one more to end. Okay, so I'm not sure how well this looks on the screen. So I'll just say it out loud. Okay, this is 280, and this says 70 in case you can't read that. That's 70. This is 280, and this is 20. This one says D, so that's the distance. That says meters. Okay, so Richard needs to know the distance across the pond below. Use similar triangles to help him find the distance. Okay, so these two triangles are similar by angle similarity. Okay, this is parallel to that. So you have corresponding angles congruent, and this angle is in common to both. Okay, so let's select my proportion and let's solve. This is labeled with a D, so I'll just use D for distance. 20 over D equals, make sure all your numerators come from one triangle and make sure all your denominators come from the other triangle. 20 over D equals 280 over 350, because that entire side is 350. Suppose you accidentally use 70. Suppose you accidentally put 70 there. It's a very common mistake. But if you put 70 there, and you solve for the distance, you're going to get the distance equals 5. And that clearly does not make sense. That is bigger than 5. Right? It's bigger than 20 because that's 20. So this is definitely bigger than 20. So if you accidentally use 70 there, your answer won't make sense. Okay, let's cross multiply and solve. 280 times d equals 20 times 350. So 280 times d equals 20 times 350 is 7,000. Divide that by 280. D, distance, equals 25. So distance across the pond is 25 meters. So I know these were word problems. I know most people don't like word problems, but I don't think these were that bad. I mean, I think you had the picture for all of them. I suppose we could do some where you're not given the picture, but I don't think these were that bad. Okay, just make sure you write the right proportions and just solve them like we've been doing, and you should be fine. Okay? Similarity word problems.